This video covers Morehouse's homework for Wednesday, September 14th. Question 1. Here's a table that shows the ratio of flour to water in an art paste. Complete the table with the values in equivalent ratios. I know that for every 1 cup of flour, I need a ½ cup of water. I'm looking for an equivalent ratio where now I have 4 cups of flour. We can think about this in the table, or we can think about it outside the table. In the table, I can see that I'm multiplying cups of water times 1/2 to tell me how many cups of flour there are. Since half of 1 is 1/2, I can see that I'm multiplying 1 by 1/2 to get the correct number of cups of water. Similarly, I'll need to multiply 4 by 1/2 to tell me how many cups of water belong with 4 cups of flour. 4 times 1/2 is of course 2, half of 4 is 2, and so I know that I need 4 cups of flour for every 2 cups of water. Another way to solve this row of the table is to create an equivalent ratio. I know that my ratio of flour to water is 1 to 1/2. And I know that I'm looking for a ratio of 4 to something. Remember, ratios are equivalent when we can multiply both sides of the ratio times the same number to get the second ratio. 1 times 4 is equal to 4, so I know that I need to multiply 1/2 times 4 to find the missing number. 1/2 times 4 is of course 2, which is the same thing that I got using the other method. This simply demonstrates that we are able to use multiplication across the table or find equivalent ratios to figure out the missing values in tables. In the next row, you'll need to work backwards, so something times 1/2 is 3. And in the final row, you can use the same process that we used in the second row of the table. Pause this video to finish question 1 and come back for a homework helper on question 2. Question 2. This year, Central Middle School is having a bake sale. 2 teams of students bake cookies. Right away, I can tell that this is a big problem. There's a lot of text, so I'm going to make sure to annotate. I know there are 2 teams of students who are baking cookies. First, we have Josie's team, who puts cookies in 8 boxes with 36 in each box. Then we have Richie's team that puts cookies in bags of 20. You can see on the right side of the diagram, we have a diagram, or on the right side of the screen, here we have a diagram to show this situation. The 2 teams bake the number of cookies to fill 8 boxes and 12 bags, as shown in the picture. 8 boxes, and we have 12 bags. Question 1 says, how many total cookies did the students bake? Explain your answer using numbers, words, or pictures. You have these diagrams to show you how many cookies there are in each box or bag, and how many boxes and bags there are together. You can go ahead and pause this video to answer question A. Then I'm going to give you a hint on question B. Question B says, how many more cookies are in 5 boxes than 5 bags? Explain your answer using numbers, words, or pictures. I want to encourage you to read the diagram closely. We can see that we have 5 boxes highlighted and 5 bags highlighted. The question is, when we compare those 5 boxes with those 5 bags, how many more cookies are there in the boxes? You'll have to do some counting. Pause the video for B, and then we'll take a look at question C together. After the bake sale, 1 box and 1 bag of cookies remained. The organizers gave the remaining cookies to the 6 students on the team. Each student received the same number of cookies. What's the largest number of cookies each student could have received? How many extra cookies would be left after the student received that number of cookies? So, you know how many cookies were left over, and you know how many students they're being split up between. If they're all getting the same amount, what is the largest number of cookies each student could get? That's question C. Go ahead and pause this video before I give you a helper on the next page. Remember, you can always rewind or pause again if you're not ready for the next question. The last question I'll go over is question 4. Compare the fractions below by writing greater than or less than on the lines. Give a brief explanation for each answer, referring to the benchmark of 0, 1/2, and 1. Let's take a look at A. In A, I know that 1/2 is greater than 1/4. The reason is that 1/4 is less than 1/2, and it's closer to 0. One way to think of this fraction is on a number line. 0, 1/2, 1/4. Your explanation could be that simple. You could also explain it by drawing a little picture underneath the fractions like we've been practicing in class to show me that you recognize that 1/4 is exactly a half of a half. When we compare fractions that are a little bit less obvious, like B, 6/8 and 1/2, those pictures will help us to see exactly what we're comparing. I can split my circle into eighths and color in 1, 2, 3, 4, 5, 6 of those eighths to identify that 6/8 is greater than a half. You could also write something like 6/8 is closer to 1 than 1/2 is. Any explanation that tells me you understand the difference between two fractions would suffice, but don't forget the explanation part. That's the end of the homework helper for Wednesday. Thursday is simply fluency, so this will be the last homework helper for this week. If you have any questions, remember to check in with me during homeroom hours.